Welcome back to Max with RP. We are going to discuss problems based on local maxima and minima. So find the points of local maxima and local minima, if any, for f of x equal to x minus 3 the whole power 4 on R. So we have f of x equal to x minus 3 the whole power 4. So what is f dash of x? F dash of x will be 4 into x minus 3 the whole power 3. See, x, it's of the form x power n x to the power n minus 1 is the derivative. Now f dash of x equal to 0 implies x minus 3 equal to 0 or x equal to 3. So we are going to use the first derivative test, that is the intervals of increase and decrease, to find local maxima and minima. So this is the critical point. What is this called? This is called as the critical point. Okay. So now if you look at the entire real line minus infinity to infinity, the critical point is 3. That is the point where if I draw an horizontal tangent to the, if I draw a tangent to the curve, it's going to be parallel to the x-axis. It's going to be horizontal and its slope will be 0. The tangent line will have slope 0. So, okay. Now, how do you find a function is increasing or decreasing? We look at the sign of f dash of x. So, first you have the class intervals. I'll just write intervals. Sign of f dash of x, nature of f of x. So what is the first interval? Minus infinity to minus 3. There are only two intervals. Minus infinity to 3 and 3 to infinity. Okay. Now take any point in this, okay, and look at, let us substitute in f dash of x. This is f dash of x. So what will be, let us choose a point in this interval minus infinity to 3. So let x be 1. F dash of 1 will be, in this you have to substitute 4 into 1 minus 3 is minus 2 cube. So minus 32. Minus 8 into 4, 32. So it is decreasing. See, the way I draw itself, it should indicate, my arrow itself should indicate how the function is decreasing up to 3. Okay, what happens to the right of x equal to 3? So what I can take a value from there, say 5. What is f dash of 5? F dash of 5 will be 4 into 5 minus 3, 2 cube. This is plus 32. Therefore, it is increasing. So, what do you see here? Decreasing, increasing like a valley. I have told you. So, that what is x equal to 3 is a point of local minimum. So, minus infinity to 3, it is negative. The function is decreasing. Positive, the function is increasing. You must show these values. These calculations are important. Okay. We don't want any of you to guess. We should conceptually understand and prove whether it is increasing or decreasing. Now, because the function is decreasing and then increasing, x equal to 3 is a point of local minimum. Is it clear? You can also see the value, how it is the point of minimum. Let's look at this problem. F of x is 2x cube minus 6x square plus 6x plus 5. We have to find the points of local maxima and minima, if any. So what will be f dash of x? 6x square minus 12x plus 6. This is 6 into x square minus 2x plus 1. This is 6 into x minus 1 the whole square. Now, you know that x minus 1 the whole square is always positive. X minus 1 the whole square is greater than or equal to 0. When x is 1, it is 0. Otherwise, it is positive. Okay. Therefore, f dash of x is greater than or equal to 0. So, but what is the critical point? If f dash of x was 0, then x is 1. So, the only point of contention is x equal to 1. Now, let us see what happens at to the left and right of x equal to 1. I have already mentioned that this is a positive quantity. Being a square, it is a positive quantity. So, f dash of x is always positive. So, it is increasing. So, what if you get like this and still have a critical point at x equal to 1, we have also discussed examples with cubic functions to say that x equal to 1 is a point of inflection. What is x equal to 1 called? It's called as a point of inflection. There will be a bend to the curve. There will be a bend in the curve, okay, but the function will continue to increase, okay, because the derivative is positive. It's an increasing function. It will go on increasing. But then what happens at x equal to 1? There's a small bend and then it continues to increase. So such a point is called point of inflection. F of x equal to x into root of 1 minus x, where x lies between 0 to 1. So what is your f dash of x? Product rule, x into minus 1 by 2 into root of 1 minus x plus root of 1 minus x into 1. I have just used product rule, okay. Now this will be, when on simplification, 2 into root of 1 minus x, okay, then minus x plus this into this will give you 2 into 1 minus x. So this is minus x minus 2x minus 3x. So 2 minus 3x by 2 into root of 1 minus x. So if f dash of x equal to 0, then 2 minus 3x is 0 or x is equal to 2 by 3. Okay, so this is the critical point. So x equal to 2 by 3 is a critical point. So now we have to study the behavior of the function to the left and right of x equal to 2 by 3. So I have x equal to 2 by 3. In fact, I can look at a minus infinity to infinity and then I can very easily talk about 0 less than x less than 1. Okay, to the left of x 2 by 3, okay, if I substitute, what will I get in f dash of x? We know that f dash of x is 2 minus 3x by 2 into root of 1 minus x. Let me find out what is f dash of 0. I can substitute 0 for to choose a point left to the left of 2 by 3, x equal to 2 by 3. When f dash of 0 will be, you know that this is 2, this is 2 by 2 which is 1, okay, which is greater than 0. Okay, so the function is increasing. What about to the right of 2 by 3? Let us choose f dash of, see why as a given x is less than 1, if I take x is greater than 1, then you will have to find the square root of a negative number. It does not make sense. That is why they have restricted the domain to 0 less than x less than 1. Okay, so I have to choose a value which is slightly greater than 2 by 3. Okay, let me choose say 0.8. Okay, 2 by 3 you know is 0.6 something, so I am choosing f dash of 0.8. So what will I get? 2 minus 3 into 0.8 by 2 into root of 1 minus 0.8. So this is positive. 1 minus 0.8 is also positive. What about 2 minus 3? 2 minus 3 into 0.8. 3 into 0.8 is minus 3 into 0.8 is minus 2.4. So 2 minus 2.4 is less than 0. So it is decreasing. So till only 1 it is defined, because beyond that the function is not defined. Root of 1 minus x is not defined. So if I take 0 to, okay, 0 to 0 less than x or less than 1, you can see that actually it is increasing and then decreasing. So what can I say about x equal to 2 by 3? If it is increasing and decreasing, if you see a mountain, then by first derivative test, x equal to 2 by 3 is called as a point of local maximum. So in the previous sum, we saw an example of a point of local minimum. In this function, we see that at x equal to 2 by 3, we have a local maximum. This function is defined between 0 to 1, x into root of 1 minus x. We see that to the left of 2 by 3, the function is increasing, and to the right of 2 by 3, the function is decreasing. So x equal to 2 by 3 is a point of local maxima. Next problem. F of x equal to x minus 2 the whole power 4 into x plus 1 the whole cube on minus 1 comma 5. So f of x is x minus 2 the whole power 4 into x plus 1 the whole power 3. So what will be f dash of x? X minus 2 the whole power 4 into 3 into x plus 1 the whole square. I am using product rule, plus x plus 1 the whole cube, 4 into x minus 2 the whole power 3. Okay, so what is common now? X plus 1 the whole square is common. This is common, and x minus 2 the whole power 3 is common. So what are we left with? So I have x plus 1 the whole square I have already written. X minus 2 the whole cube I have written. So 1 x minus 2 into 3 will be left here, plus 4 into x plus 1 the whole cube. I have already written x plus 1 the whole square, so I will have 1 x plus 1. X minus 2 the whole cube has already been written. So this is x plus 1 the whole square into x minus 2 the whole cube into 3x plus 4x is 7x minus 6 plus 4. So this is x plus 1 the whole square, x minus 2 the whole cube into 7x minus 2. This is 3x plus 4x is 7x, minus 6 plus 4 will be minus 2. Okay. Now, if f dash of x were equal to 0, critical points will be minus 1, 2 and 2 by 7. If 7x minus 2 is 0, x is 2 by 7. So I should write it in this order. Minus 1, 2 by 7 and 2. These are the critical points. Minus 1, 2 by 7, 2. Minus 1, 2 by 7 and 2. and they have asked you to find only to the right of -1 and less than 5. Okay. So now, how do we have to check for the sign of f dash of x? Now, f dash of x is, as you know, x plus 1 the whole square into x minus 2 the whole cube, which is x minus 2 the whole square into x minus 2 into 7x minus 2. I have written like this because when I substitute values and check, I need not substitute here, because both of them being square, they will always be positive. So let me first check -1 to 2 by 7. Let me take f dash of 0. F dash of 0, I don't have to worry about these two. I have to worry only about the last two factors. So when x, this is 0, this is -2. This is 7 into, this is 0 into -2, which is 4. I am substituting x equal to 0. So f dash of 0 will be -2 into -2, which is 4. So between -1 to 2 by 7, the function is increasing. What happens between 2 by 7 to 2? So I have to choose a value between 2 by 7 to 2. Now, can I choose 1? So let us see what happens to f dash of 1. F dash of 1 will be 1 minus 2 into 7 minus 2. -1 into 5, which is -5, which is less than 0. So the function is decreasing. What happens beyond 2? Because we are given the closed interval -1 to 5. So let us look at, so I have found f dash of 0, I have found f dash of 1. These are what I am using to make my to make my summations, that this is increasing, this is decreasing. These are this is the information that I am using. Now beyond 2, I have to give a value. So what will be f dash of 3? F dash of 3 will be, again I have to substitute only this factors. 3 minus 2, which is 1, 21 minus 2. 7 into 3 is 21, 21 minus 2, 19, which is greater than 0. So the function is increasing. So what do you observe? What is x equal to 2 by 7? This is, you have a mountain at x equal to 2 by 7. So this is a point of local maximum. Because to the left it is increasing, to the immediate right it is decreasing. At 2 you have a valley. This is a point of local minimum. To the left it is decreasing, to the right it is increasing. So x equal to, so conclusion. So x equal to 2 by 7 is a point of local maximum, and x equal to 2 is a point of local minimum. So, and what the procedure that we are using is called as the first derivative test, because we are using the first derivative to make our conclusions. Okay, we are looking at the sign of f dash of x and we are concluding whether it is increasing or decreasing. That is why, since we are using first derivative to make our conclusions, we are going to call this as first derivative test. Now consider f of x equal to sine 2x minus x, where x belongs to minus pi by 2 comma pi by 2. What will be f dash of x is what we are going to see. Now f of x is sine 2x minus x. So f dash of x will be 2 cos 2x minus 1. F dash of x equal to 0 implies cos 2x equal to half. If cos 2x is equal to half, what are the possibilities for 2x? Pi by 3. We know cos 60 is half. So pi by 3. And cos is positive only in the first and the last quadrants. So the last quadrant, it will be 2 pi minus pi by 3. So this is 60 degrees and 300 degrees. And also you know cos of minus theta is cos theta. Same as cos theta. So it will be minus 300, minus 60, etc. But we have to restrict ourselves to minus pi by 2 to pi by 2. So I need to vary only about this minus pi by 3 and pi by 3. So look at the real line. I am going to look at minus pi by 3. I am having minus pi by 2 to pi by 2. Okay. I want to look at minus pi by 3 and plus pi by 3. This is minus 90 degrees. This is minus 60 degrees. This is 60 degrees. And this is 90 degrees. Okay. Now, so let me first find out whether function is increasing or decreasing in each part of the subinterval, in the intervals. Minus pi by 2 to minus pi by 3. Minus pi by 3 to pi by 3. Okay. Minus pi by 3 to pi by 3. So can I take 0? So what will be, what is f dash of x? F dash of x is 2 cos 2x minus 1. Okay. Now, if I take x is equal to f dash of 0, f dash of 0 will be 2 cos 0 minus 1. This is 2 minus 1, 1, which is greater than 0, because cos 0 is 1. So, minus pi by 3 to pi by 3, the function is increasing. Okay. Now, I have to find between pi by 3 to pi by 2. I have to take some value. Okay. In fact, I am going to just take 75 degrees. Suppose I want to find 2 cos x equal to, okay, 75. Then 2x will be 150 degrees. So f dash of 75 degrees will be 2 cos 150 minus 1. This is 2 cos of 180 minus 30 minus 1, which is 2 into minus cos 30 degrees minus 1. Minus cos 30, you know, is minus root 3 by 2. Minus root 3 by 2 into, so this will become f dash of 75 . So f dash of 75 degrees is equal to 2 into, okay, minus cos 30 is minus root 3 by 2, right, minus 1. This is minus root 3 minus 1, which is less than 0. So the function is decreasing. So cos of 2, you see the derivative involves the cos function. What is the derivative? Derivative is 2 cos 2x. Okay. So suppose I want to find a value between this and this, I can take minus 75. So f dash of minus 75 will be what? 2 cos minus 150 minus 1. This is cos of 2 into cos of minus 150 is cos 150 minus 1. So this is, we have already checked. This is less than 0. Okay. Are you able to follow? So x equal to minus pi. So this is a point of local maximum. X equal to pi by 3 is a point of local maximum. X equal to minus pi by 3 is a point of local minimum. Are you able to follow? So we have been doing even in our earlier sessions about increasing and decreasing. We are now just extended the idea to conclude whether a function has local maxima or minima. If it is decreases and increases, you have a point of local minimum. Increases and decreases, we have a point of local maximum. Okay, and since we are using the first derivative to make our conclusions, this is called as the first derivative test. So by first derivative test, we can conclude that x equal to minus pi by 3 is a point of local minimum and x equal to pi by 3 is a point of local maximum. I hope you have got some idea about local maximum and minimum. Please work on these problems, similar problems where we have solved for increasing, decreasing. You can use the same problem and check where you have local maxima and minima. That will give you a kind of good intuition about the concept of maxima and minima. So in the next video, we will work on absolute maximum and minimum. Until we meet next time, it's goodbye. I hope you're enjoying the session Max with RP. If you do and if you find this useful, please share it with your friends. Thank you.